Hello students, a very good morning to all of you. Ashit Shikhar, Lakshmi Menon, Minakshi, Rupam, a very good morning to all of you. I hope you had a great day yesterday and today also I promise and you should promise to yourself it should be a great day. Yes students? So, we here at Career 360 Mega Revision Marathon realize that you guys are facing a lot of problem because of this lockdown as the offline coaching sessions are closed. So here we are for your rescue to assist you in your preparations. So we have come up here at Careers 360, we have come up with a online mega revision marathon, and we aim to assist you in your studies, and as well as we wish that in your plan of action you include whatever lectures we are delivering, and that would help you that would help you a lot. So okay students, today's session, what was the today's session? Tell me. Vector algebra. Yes, you got it right, it is vector algebra. So vectors, first of all we'll start with a 3D coordinate system. Everybody understand? There are x, y, z coordinates. So this is not new. So this is just to show you that at any point P, x, y, z, its distance from the xy plane is the coordinate z. That's what it has been shown. Hai? So z coordinate is the distance from xy plane, that way. Then we come to the octants. The octants, you see, you should have a visualization of all the octants. Hai? Like for example, in xy plane we have quadrants in, yes Samit Kumar, why is it like this? What? I don't understand what you are referring to. So these are the octants, as if it's a 2-floor story building in which at each floor there are 4 rooms. It's like that. Okay. So this is a representation of octant. So we have 8 octants, and these are the sign conventions in every octant. Okay. So we'll not go into a lot of detail of this. Okay. Snigdha, there is no requirement of explaining you the signs, but you have to understand. That whenever we move on to the positive x-axis, there it would be plus, negative x-axis negative. So if we look at the previous slide, if you look at this quadrant, you would realize that this quadrant has a negative x. This quadrant I'm referring to, x-axis is this one. So this is positive, x is positive, y is negative. The y goes that side opposite to this y, so that is negative, and z is positive in this octant. Okay. Yes, Chinmay Joshi, good morning. So we come to the next slide. So this is what we did. These are the octants. Okay, no problem. Jatin Raj, good morning. Join us. Yes, Nigda, my pleasure, beta. Then you know what is the difference between vector quantity and a scalar quantity. We have read quite a lot in physics, but still let's go about it. Scalar quantity is a quantity which has magnitude but no sense of direction, like mass, volume, density, etc. And scalars in mathematics, we call them as numbers, right? Vector quantity is a quantity which has magnitude as well as a sense of direction in a space. And this is very important. Obey the laws of vector algebra. That's highly important, because even though there are certain quantities which have direction and magnitude, but if they don't obey the law of vector algebra, then they are not called as vector quantities, they are called as tensor quantities. For example, current. Whenever you show in a circuit current, it has got a direction, it has got a magnitude, but it does not obeys the laws of vector algebra. है ना? So we cannot call current as a vector. Okay. So let's move on to the next question. Next slide. Next slide is representation of a vector. Rajkumar, live class started at 8:30. Shashi Prakash, good morning. Now let's look at this representation of a vector. I hope everybody knows that, but just a quick revision. A vector in a plane is represented by a directed line segment. So a line segment directed, that directed line segment means which has an arrow on one side. The endpoints of the segments are called initial point. So this is the initial point, which is also known as tail, and the terminal point. Terminal point is Shideshwar, good morning. Ashad Shekhar, good morning. Yes, come on students, let's do it. And this is known as head. This is the terminal point. Okay, and ABA without the vector head on it, that is known as magnitude or the modulus of a vector. Okay, Tarun, yes, good morning. Good morning, Senthil. So how do we represent the modulus? This is mod of A or mod of AB. It's represented like this without the segment head. Okay, then we come to the next topic, position vector of a point. Now this is very important. One has to understand what is position vector of a point. Now whenever we have plotted a point on 3D, if from the origin we join that point, a straight line joining origin as an initial point and the point P as the terminal point of the vector, O is its initial point and P is its terminal point, then this vector is known as position vector of that point. Okay, Sidhu will be doing sums, examples I'll be solving. You'll not be solving, but you will look at the some examples which I'll be solving. Okay, now what is the magnitude of the vector OP? Right, if OP is the position vector of point P, then OP is given by under root x square plus y square plus z square. This is very simple because this everybody, most of you know. Okay, now here any vector r in three-dimensional space can be expressed as r is equal to xi cap plus yj cap plus zk cap. Now what is xi, yj and ijk? What are those? Ijk are the unit vectors. Yes, Ashashikar, today total theory and example sum. Okay, tomorrow we'll be practicing questions on vectors. So any vector can be expressed in as a linear combination of I, j and k. So let's see how. So for example, I is a unit vector along x-axis. Okay, j is a unit vector along y-axis and k is a unit vector along z-axis. So if xi would be some multiple of I, so this is OQ, and OS is some multiple of j, let us say yj, that is this vector. Now if I add these two vectors, I'll get this vector as a resultant. Now if I add, Hardik Jain, good morning. Saran SVS, good morning. Yes, please join us. And this vector OR is nothing but ZK. Okay, now this vector OP and this vector OR, if I take the resultant of this, mind you, this is 90 degree. So if I take
the resultant of this would be the vector OP. So the resultant of OP would nothing it would be but the sum of xi plus yj. That is the first thing which we did. That was OP1 vector. And then I added OR vector to it, which is zk. That is OR vector. And that finally gives me the vector OP. I hope you understand. Yeah, it is helpful for board exam as well, but yeah, it is helpful for board exam as well. But board exam we are not aiming at, we are aiming for JEE Main, Hana? Yes. Good morning, Mala. Good morning, Sanjay. Yes, join us. So here we go on. So I hope you understand how any vector can be expressed as a linear combination of ijk. This is called a linear combination. Linear combination, some multiple of I, some multiple of j, I mean a scalar multiple, some multiple of k, and addition of all those. Okay. So let's look at the next slide. Vectors joining 2 points. Yeah. So I mean, this is, for example, we have a vector like this. Okay, this is a directed line segment. Whatever is this point, let's say this point is A. So it has some coordinates x1, y1, z1, है ना? And the tail vertex is B, and this is x2, y2, z2. Okay. Yeah, it is useful for B Arc Maths as well. Amit Sharma, a very good morning. So, do you realize this vector would be known as BA vector? I mean, the terminal you write it last. Initial point you write it first. So, BA vector is given as the difference of these two vectors, है ना? Difference of these two vectors. That is x1 minus x2 I cap plus y1 minus y2 j cap plus z1 minus z2 k cap. And if I choose to write AB vector, that means the initial point is A and the final point is B, then we will write it as x2 minus x1 I cap and so on and so forth, y2 minus y1 j cap and z2 minus z1 k cap. So here it has been shown that why it happens like that, because A position vector would be this, B position vector would be this. If I make use of vector law of algebra, triangle law of addition, है ना? Which law I referred to? Triangle law of addition. In fact, subtraction. Triangle law of addition. We always call it addition, and here we also use subtraction. So this vector would be the result OA. If you realize, OA plus AB is nothing but OB. So what would be AB equal to? AB would be equal to OB minus OA. That's what I've done here. Okay, students, I hope you are getting it. So let's go ahead. So that's how we represent AB and BA vector. Now let us look at the type of vectors. Yes, Achit Shekhar, understood it? Now types of vectors, there are so many type of vectors. We'll quickly have a glance over them, like coplanar vectors, collinear vectors. Yes, Rashmi? So we have a zero or a null vector. What is a null vector? Null vector is a vector whose initial and terminal points coincides. Okay. So why do we require a zero vector? Hannah, can somebody tell me? If the vector does not exist at all, then what? What is its requirement? Tell me. Why there is a requirement of zero vector in vector algebra? Can anybody answer me my question? Actually, whenever you write a vector equation, let's say I write A plus B. A is some vector, B is some vector. Let us say C is some vector. And I write a vector equation and I write it equal to 0, then it would be wrong. Because on the left hand side vectors are there, right hand side there should be a vector in fact. So that's why we write a null vector like this. And that completes the vector equation. Okay. Yes, Tina, I'll speak about the direction as well. A vector whose initial and terminal is zero vector and is denoted by this. The magnitude of a zero vector is zero and direction of zero vector is arbitrary. This is very important. There was one question in which it was being asked that the direction of zero vector is. The first choice was not defined. Then there was a choice like uh, directionless. And then third, it was something like arbitrary. That is what was the right answer. And fourth one was not none of these. Then arbitrary is the correct answer. Okay, arbitrary. Direction is arbitrary. So it is not defined. No, direction of zero vector is defined. Directionless. No, it is not directionless. It is arbitrary. Okay, students. So we go ahead. Null vector we have done. Then we have unit vector. Unit vector becomes very important. A vector whose magnitude is unity is called a unit vector. So a unit vector in the direction of a given vector is arbitrary, means which can have any direction. That's what arbitrary means. It can take on any direction. Tarun, I hope you understand. It can take on any direction. That is zero vector. That is the meaning of arbitrary. Okay. So I hope you understood. Now unit vector, suppose this is a vector, and if I talk about a upon mod a, this would be a unit vector in this direction. That means whose magnitude is unity. Okay. So this is a unit vector. In one unit, that would be the magnitude. Okay. So this way we completed this one as well. Now, so two or more vectors having the same initial points are co-initial vectors. So that's initial points, co-initial vectors. That's easy to understand. We go further. After co-initial vectors, we have collinear vectors that all are aware of, I think. Two or more vectors are said to be collinear if they are parallel to the same line, irrespective of their magnitudes and directions. That means collinear vectors can be in opposite direction as well. Okay. So tell me, 3i cap and minus 4i cap, are they collinear or not? Yes, they are collinear. Equal vectors. Two vectors a and b are said to be equal if they have the same magnitude and direction. So they have the same magnitude and direction regardless of the positions of their initial points. Okay, written as a is equal to b. So regardless of the positions of their initial points. Okay, then we have negative of a vector. Negative of a vector is having the same magnitude but the direction having exactly opposite to the vector. Okay. So we quickly glance through these concepts. Coplanar vector lying on the same plane. Okay. All the vectors lying on the same plane. Then direction cosines and direction ratio. I think this becomes a very important point to understand. I hope nobody is confused in this. Direction cosine and direction ratios. Now what are DCs? Direction cosines are also known as DCs. So listen, suppose this vector we are talking of, OP. Okay. Now it is obviously making some angle with x-axis. Let us call that alpha. It is making a certain angle with y-axis. Let us call that as beta. And it is making a certain angle with z-axis. Let us call that as gamma. Okay. Then, yeah, we'll come to that, Tarun, parallelopiped. Then DC, direction cosine, will be the cos alpha, cos beta and cos gamma. Cosine of this alpha angle, cosine of this beta angle and cosine of this gamma angle is the direction cosine of the vector OP. I hope you understand. Cos alpha will be denoted by L, cos beta will be denoted by M, and cos gamma is denoted by N. Rashmi Soni, what's your question? Minus
5 vector is negative vector of 4 vector? No. Minus 5 vector is negative of 4 vector? No. Negative of a vector will have the equal magnitude. Okay, it will have an equal magnitude. So direction cosines you understood? Now, once you have understood the direction cosine, please understand the direction cosine direction ratio concept as well. Now, this what I explained you in the previous slide. Let's have a look. So cos alpha, I have I for example I defined cos alpha. This was alpha, है ना? This was alpha. The angle made by the OP vector with the x-axis. Now, this cos alpha, how would you get cos alpha? Cos alpha would be x. Now, what is x? X is the distance of the coordinate P from YZ plane. है ना? So, if you realize, then let me make it like this. This is x-axis. You generally see x-axis in this way. And this is the vector OP. I make a 2D figure. Okay? OP. And it is making an angle alpha with x-axis. So from here to here, distance from YZ plane to the point P projection, that is x coordinate, and the modulus is r. So can you write cos alpha in this right angle triangle? X is the base, r is the hypotenuse, so it would be x by r. Am I right? Okay, everybody everybody understood? The x by r is equal to cos alpha. That's how. So that's what I wrote it here. Similarly, cos beta would be y by r and cos gamma would be z by r. So cos alpha, r is nothing but the modulus of the vector. So it would be under root x square plus y square plus z square. So we have cos alpha, which is represented by L, M and N. This is what I wrote in the previous slide. Okay. So we go on to the next concept, है ना? And that would be the, by the way, we want to find a relationship between the direction cosines. Okay. So what's the relation between direction cosines? That is, if I write L square, that is, Arun, good morning. How many topics are left, Jatin? We are just at the initial stage. We'll be doing dot product, cross product, scalar triple product, vector triple product. So L square would be x square and the under root sign will go m square, I get n square, I get. So if I add these three, then what do I get? The denominator is same in all these cases, so it would be 1 because x square plus y square plus z square will cancel with the denominator. So this is the relation. Somebody in some test, it was asked, good morning beta. Okay, in some exam it was asked, what is sine square alpha plus sine square beta plus sine square gamma? And of course, you convert sine square gamma, sorry. What is this equal to? Can somebody answer me? Can somebody answer me? What is sine square alpha plus sine square beta plus sine square gamma? So that would be, you'll convert them into 1 minus cos square alpha, 1 minus cos square beta, 1 minus cos square gamma. So it would be 3 minus 1, that is 2. Okay. No, Tarun, no, it's not 1, it's 2. 2. Yes, Siddharth, you're right only. So, the coordinates of the point P may also be expressed as LR, MR, NR. Now, this is where it becomes important. What is the concept of direction ratio? Why it is important? So, let's look at the concept of direction ratio. Now, this is a definition which we always expressed, that the numbers LR, MR and NR are the numbers proportional to the direction cosines, and they are direction ratios. But I would like to elaborate on this point. Okay. Now, whenever you have any vector,
any vector in space. Let's say any vector in space A is 4i cap plus 7j cap minus 8k cap. Okay. Now 4, 7 and minus 8 will be the direction ratio of this vectors. That's what here it is expressed LR, MR and R. And if there is a unit vector, any unit vector, let's say B unit vector I am taking. Let's say it is 1 by 2 I cap minus 1 by 2 j cap 1 by 2 and 1 by 2 I should get. So 1 by root 2 k cap. Okay. Now this is a vector in which the magnitude of this vector is 1. So half minus half, the coefficient of ijk vectors are the DCs of the vector, direction cosines only. Okay. So what do I construe? I construe that it is the coefficient of ijk in a unit vector are nothing but the direction cosines, and in any vector the coefficients of ijk are the direction ratios. I hope you understand. Hello students, I want an answer. Do you understand it? Okay. Now let us have a look at this. If R is this, then ABC are the direction ratios of the, that's what here it is expressed. The same thing which I expressed it earlier, that A, B and C are the direction ratios of the given vector, and if it's a unit vector, then A and B, C will be the direction cosines. That's the same thing which I explained you in the previous slide. Now addition of vectors we come to. Okay, addition of vectors, there are two rules: triangle law of vector addition and parallelogram law of vector addition. What's the difference? Tell me. Triangle law of vector addition and parallelogram law of addition. Okay, addition we are discussing. So when we talk about triangle law of addition, we add two vectors from head to tail. Okay, so we have first triangle law of addition, and the second one is parallel law. Although basically they lead you to the same result, but what is the difference between them? So triangle law of addition, there are two vectors, let us say A and B. Okay. Now A and B are to be added. So if I add, this is A, if I add in a manner that I displace B parallelly, vectors has a property of displacing it parallelly. This is B, we can displace it if the vectors are localized vectors, free vectors, sorry. If they are local vectors, then they cannot be freely shifted. So this is A plus B. This is triangle law of addition. Okay. Parallelogram law of addition, if I add these two vectors tail to tail, so this is A and this one is B. So I'll complete the parallelogram, and the diagonal, which is the co-initial vector, that would be A plus B. Although the result in both the cases would be same, but the difference should be apparent to everyone. Okay, should be understood by everyone. Okay, subtraction of vectors, you write the vector as A minus B. So A minus B in parallelogram law vectors, it is the other diagonal. Okay, so if we talk about other diagonal, that means which is the that is the one which is not co-initial. Okay, in parallelogram law vectors, subtraction of vectors is given by the other diagonal, and in triangle law of addition, we draw, instead of A plus B, we do A plus of minus B. है ना? Okay, I hope subtraction of vectors is clear. Then let's look at this polygon law of addition. What's that? So if a number of vectors can be represented in magnitude and direction by the sides of a polygon, how can sum of two sides in a triangle be equal to the other side? Shouldn't it be greater? Siddharth,
what's your question? Sum of two sides on a triangle b equal to, when we are talking about that's a vector equation. I mean, I'm not adding the magnitudes, I'm adding them vectorially. I hope you understand. We are talking about vectors, we are not talking about magnitudes. Okay, Siddharth, I hope I answered you. When I write a plus b is equal to c, that doesn't mean that I'm adding the magnitude of a and magnitude of b and I'm saying it that is equal to c. Okay, Siddharth, is your query cleared? Then what do we have? Polygon law of addition. So we say if if a number of vectors can be represented in magnitude and direction by the sides of a polygon taken in the same order, then their resultant is represented in magnitude and direction by the closing side of the polygon taken in opposite order. Okay, so here they have shown you what hexagon. So this AB plus AC, BC plus CD plus DE plus EF is equal to and plus FA, that is till here only, till EF. So that would be the closing vector. That would be equal to this vector minus F. Okay. So I hope everybody understand. So can somebody answer me that for a quadrilateral, if yeah, tell me otherwise, if the vectors, please listen everyone, if the sides of a quadrilateral are represented as vectors in cyclic order, then what will their sum be equal to? So I have this, I'll say it again, if the sides of a quadrilateral, they are represented in cyclic order, this is AB vector, what will their sum be equal to? Yes, tell me. 0. Yes, Sanskriti, you're right. Why? Because according to the polygon law of vectors, AB plus BC plus CD is nothing but minus DA. Okay, that is minus DA. Yes, Rashmi, you're right. So minus DA, you bring it here. That's what we did in the next lecture, in the previous slide. CD and plus DA would be equal to 0. So you have to remember that if you are talking about a triangle and this is side A, this is side B, and this is side C, and if it makes a cyclic order means this vector goes this way, then this vector goes this way, and this way as I am showing. So A plus B plus C would be equal to what? 0. Am I right? That's how. 0 vector, I mean. Okay, students? So we move on to the next topic, that is properties of vector addition. So it is commutative, it is associative properties there, additive inverse and additive identity exists. Okay, then properties of vector subtraction. Obviously, subtraction is never commutative, it is never associative, and yes, these inequalities. Now here I can make a point which earlier the student raised about the side, how can the sides of sum of two sides be greater than the third side. Now here we are talking of the magnitude of first one side of a triangle, magnitude of other side of a triangle will always be greater than or equal to the third side, and this way these are all important. Okay, then let's talk about a question. Let A is this and A plus B is this, then B equals to. So I think this simple only. B would be equal to I minus J minus K minus A, Hana? So this we can do. So what would B be equal to? B will be equal to I minus J minus K. Can somebody quickly answer me? Minus A. That is I minus J minus K minus A vector is 2I plus 3J cap plus K cap. So what do I get? I
minus 2i will give me minus I cap. Minus j minus 3j would give me minus 4j cap. Minus k cap minus k cap, that gives me minus 2k cap. Am I right? So that would be B vector. Okay, student, that was easy. So great going. Okay. Yes, let's go ahead. What's the next topic? Multiplication of a vector by a scalar. Multiplication of a vector by a scalar. What does it mean? Now, scalar in mathematics are numbers, plain numbers. Okay? Scalars in mathematics are numbers. That is a real number. That's what is mentioned. Okay? Obviously, we are talking about real numbers. Lambda A is a vector whose magnitude is lambda times that of A and whose direction is the same as or opposite that according to the value of lambda is positive or negative. So if there is a vector A as it is shown here, lambda A would be lambda A1, lambda A2, lambda A3. Okay, this is easy to understand. So if lambda is negative, that would be a collinear vector, but it will be an unlike vector, opposite direction. Okay. Now let's come to the next slide. Properties of multiplication of a vector by a scalar. So this all is pretty obvious. I don't want to elaborate on this. Then a geometrical visualization of multiplication of a vector by a scalar. Yeah. So here you have to understand that A is a vector, then 2a would be twice vector in the same direction. Half a would be half of the magnitude. Okay. Yes, students. Then let's look at this. We have alpha as lambda minus 2a plus b, and beta vector is 4 lambda minus 2a plus 3b. Be two given vectors. Okay, these are two given vectors. Now, what is being asked? Where vectors a and b are non-collinear, please mark it. Where vectors a and b are non-collinear. The value of lambda for which vectors alpha and beta are collinear. But alpha and beta are collinear. So when alpha and beta are collinear, I can always write alpha is equal to some scalar into beta. Okay. For collinear vectors, this is the relationship. They are linearly dependent. Okay. So when alpha is equal to mu b, I equate the b part. B is equal to I'll write it. I think I have another slide on it. Yes, here it is written. So I'll make use of this slide. So I'll assume that A and alpha and beta are given to me as collinear vectors. So alpha would be mu beta. Okay, where mu is a scalar. So when I equate it, I get lambda minus 2 a plus b is equal to mu 4 lambda minus 2 a plus 3 mu b. Okay. Now this b and a are non-collinear. So b vector would be equal to 3 mu b. So what mu value I am going to get? That is 1 by 3. Okay. Now when I get mu is equal to 1 by 3, I'll equate the a coefficient also. That would be lambda minus 2 will be equal to 1 by 3 4 lambda minus 2. Am I right? So what it would be? 3 lambda minus 6 is equal to 4 lambda minus 2. What do I get? Minus 2 goes here. So minus 4 is equal to lambda. This is the value of lambda which we get. Isn't that right, students? Yes, Varsha. Very good. Minus 4 you get. Then we move on. Hello, students. Wait on. We are supposed to do even scalar triple product, dot product, cross product. So just hang on. Internal division. So as in coordinate geometry, same way we have internal division and external division in vectors as well. But here we have to consider the vectors of point A and point B, that is position vectors only we will be considering. Here this is very important. Please note it. Here we have to make use of position vectors. Okay. I'll not like to elaborate on this point. We have external division as well, mb minus na upon m minus n. Okay, I hope this is revision sake, so you'll quickly revise on this portion. Then what do we have next? We have linear combination of vectors. Linear combination of vectors, what does it says? A vector R is said to be a linear combination of vectors a1, a2, a3 and an if there exist scalars such that R is equal to lambda 1 a, lambda 2 a, lambda 3 a3. है ना? What it basically means, linear combination of vectors, that a vector is considered as a linear combination if it is a sum of scalar multiples of the other vectors. Okay, then it is called a linear combination of vectors. For example, for coplanar vectors, what do we have? If three vectors are coplanar, how do we express that? If three vectors are coplanar, A, B and C, since I'm making it in the board of the on the plane of the screen, A, B, C are coplanar. So any vector out of these three will be a linear combination of the other two. So lambda b plus mu c. That's how you express. Okay? Lambda b plus mu c. So A vector is a linear combination of B and C. So for example, we have shown you that R1 is a linear combination of A, B and C. R2 is a linear combination of again A, B and C, but a different linear combination. Okay? I hope this is understood by everyone. So just tell me, any vector is a linear combination of I, J, K or not? Tell me. Yes? Yes or no? Answer me. Linearly independent vectors. Okay. What are linearly independent vectors? A system of vectors a1, a2, a3 is said to be linearly independent if lambda 1 a1 lambda 2 a2 is equal to 0 implies. Okay, I think there is something wrong here. Some misprinting is there. Lambda 1 is equal to lambda 2 is equal to lambda 3 is equal to lambda n equal to 0. This is linearly independent vectors. Am I right, students? Now, what linearly independent vectors means that any vector cannot be expressed as a linear combination of the other vectors. That's what it basically means. Okay? Shall I repeat it? I'm trying to say that, and suppose, in other words, I want to say that A, B, C are independent vectors. Okay? Then I cannot express, mark my word, cannot express as A is equal to lambda B plus mu C. I cannot express like this. This is what linearly independent vectors means. I hope you understood. So, if I actually have A minus lambda B minus mu C equal to 0, then in that case, this is also something, let's say gamma. Then gamma would be equal to 0, would be equal to lambda, would be equal to mu. Okay? This is what do we understand by this statement. I hope this is okay with everyone. Now, linearly dependent vectors would be in the other sense of it, that if system of vectors a1, a2, a3, an are said to be linearly dependent if there exist scalars, not all zeros, such that lambda 1 a1, lambda 2 a2, lambda 3 a3, lambda n an is equal to 0. Solve collinear vectors, coplanar vectors, they lie under this category. Acha, mind you, telling you frankly, if any four vectors are there in space, then they are linearly dependent vectors only. Okay? They cannot be linearly independent. Four vectors, as I spoke. So then we come to yes, students, dot product. Yes, we start with dot product. Dot product of two vectors. What is that? A and B are two non-zero vectors. Please mind you, we are talking only about non-zero vectors. We don't take are two non-zero vectors. Then there is scalar product. Then their scalar product is denoted by A dot B, and is defined as A dot B is mod A mod B cos theta. Okay, where theta is the angle between A and B. Now let us come to its understanding. What A dot B is a real number, A dot B is positive if theta is acute, and so on. This is easy to understand. A dot B would always be less than equal to mod A mod B, obviously, because A dot B contains cos theta as well, which is a trigonometric ratio lying between -1 and 1. So A dot B is always lesser than A dot mod A mod B. Then properties of dot product: it is commutative, it is distributive, and then scalar MA would be MA dot B would be equal to MA dot B. And similarly the fourth point, Hannah. So some important research. Yeah, this is important. A plus minus B whole square. This basically means, so you have to understand, students, here in the first point is very important, that whenever we have any vector square, A vector square, है ना, तो A vector square would mean, I mean, A dot A vector square means A dot A. Oh, what I'm writing. A dot A would mean what? Tell me. A dot A would be mod A square. Cos of 0 is the angle between them. That means if there is a vector and their mod square is there, then I can write them as A dot A. So here mod should be there. Okay, please make the correction. Okay, students. So mod A plus minus B squared, this is mod only, that is A plus minus B dot A plus minus B. I hope you understood. So this would be mod A square, because A dot A and B dot B will yield mod A square mod B square and 2A dot B. So that's how we represent. Now similarly we have this one, and if mod A plus B is equal to mod A plus mod B, what does this means? This means A is parallel to B. And if mod A plus B is equal to mod A minus B, then A is perpendicular to B. What does this geometrically signifies? It signifies that A and B are perpendicular to each other. In such a case, if you apply the parallelogram law of vectors, you realize that it becomes a rectangle, and rectangle has both of its diagonals, which are basically represented by A plus B and A minus B. This one is A plus B and this one is A minus B. Then the diagonals length of a rectangles are equal. Okay. So this is a JEE Main revision. We're not going into the depths of JEE Advanced. That we'll do later on. So this is JEE Main revision. So basically we should be very strong in our basics. The foundation should be very good. Okay. Okay. Now, Varsha, you were saying something more rectangle. I didn't get you, Varsha. Can you elaborate? Now, here we have a question. Was that? We have a question like U is I plus J, V is I minus J, and W is this. N vector is a unit vector such that U dot N is 0 and V dot N is 0. It's a unit vector. So I'll consider N as L I cap plus M J cap plus N K cap. है ना? It's a unit vector, so I have L square plus M square plus N square equal to 1. Now, the first equation given to me U dot N. U dot N means with U I'm taking dot product of N. So what do I get? L into 1, that is L, plus U dot N I'm solving. J coefficient will multiply with M, that is M. K has nothing with it. Babar, how many questions from vectors? I mean, there is no set rule, but generally from vector 3D, 2 to 3 questions are being asked. L plus m is equal to 0. That's the first equation. Similarly, v dot n is 0. So I and this is L minus j, that would become minus m, that is 0. That is the second equation. If we solve it, what do we get? L is equal to 0 and m is equal to 0. है ना? So what do we have basically then? L is 0, m is 0. Dot product is 0 given, na? That's why I wrote it 0. Okay? Now, n is a unit vector, L is 0, m is 0, and it's a unit vector, so n would be 1. So, n vector is nothing but k vector, k unit vector. So, w dot n is w dot k. So, this with k, that would be 3 only, because I dot k would be 0, j dot k would be 0 as a perpendicular, as they are perpendicular, hai na? That is 3. The answer is 3. Yes, Sanskruti, you're right only. So we have, next, let us have a look. Dot product in terms of components. This is now expressed. A and B are given vectors, then A dot B would be equal to this. Okay? And cos theta also we can find out. This is an important formula which we derive. Cos theta is A dot B upon mod A mod B. Okay, students, this is very fine. Then we go on to the next. So cos theta formula would be A dot B, that is the numerator, and mod of A, that's the denominator, into mod of B, that's there in the denominator. So this formula, no need to remember. You have to remember that cos theta is A dot B upon mod A mod B. Okay. Now, geometrical interpretation of a scalar product, it is A dot B cap. Okay, that is the projection of the vector A on the other vector. Okay, that is it. Projection of A on B, that is A dot B cap, and projection of B on A, that is B into B dot A cap. Okay. RKS title, you are saying, can you explain scalar in component once more? I would request you, RKS title, that offline video would be available, so you can always repeat it, है ना बेटा? So because it would be difficult for me to go back. Please teach in interesting way, Deepshika. Okay, I'm sorry if I'm not sounding interesting, but yeah, but this is plain theoretical portion, which on online mode can be explained in what way, I don't know. Okay, let me try to be more interesting. Okay, Deepshika. So what do we have in cross product? A cross B, that is mod A mod B sine theta n cap. Okay, what is n cap? N cap is a unit vector perpendicular to both A and B. Both A and B, that is the plane formed by A and B. And how do we find the direction? Direction of n cap, that would be by having a right hand thumb. The fingers curls from the fingers curl, we have to curl our fingers and point our thumb. The fingers should curl from this vector to this vector. I mean, you'll keep your palm on the plane formed by A and B, and then you curl the fingers from A to B. Then the thumb pointer would be n cap direction. Okay? So I hope you understood where it is the direction of n cap. Then properties of vector product. So A cross B, as the name goes, vector product, A cross B is a vector in itself, obviously. Then what next do we have? We have A cross B. A and B are two non-zero vectors. Then A cross B is equal to 0 if and only if A and B are parallel. So we have already spoken of non-zero or collinear to each other. That means this is the result. In particular, A cross A is equal to 0 means, in particular, they are saying if A cross A is taken, then the angle is 0, and
a cross minus a is taken, then the angle is pi. In both of these cases, sine of 0 and sine of pi is 0. Chinmaya, examples we'll be doing tomorrow, Hana? Chinmaya, examples we'll be doing tomorrow, and as well as little bit of explanation is to be given right now. I have only 1.5 hours in hand, so I cannot devote a lot of time on questions as of now. I'm revising the theory. Please understand, it's a revision class, so it is presumed that you know most of the concepts. I just need to revise, make you revise them. Okay. Then if theta is equal to pi by 2, we get the maximum of a cross b in terms of magnitude. A cross b is, I mean, a little mistake is there, mod a cross b. Okay, that's what you need to write. Next class timing is 8:30 in the morning, Deepshikha, and that would be practice on vectors. So we'll be doing multiple choice, we'll be doing single choice correct questions on JEE Mains pattern. Now here we have from the property 2 and 3. Okay, we were mentioning some property here and we talk about that. Okay, you make, I hope you know what is I cross j or j cross k. How do you calculate that? So let me tell you, you make a Mercedes sign, make a anti-clockwise cycle. So I cross j, when you go along the clockwise cycle, I cross j, the answer would be k. But if j cross k, if you go along the anti-clockwise way, you get the answer. J cross k will give you I cap. K cross I would give you j cap. But if you go the reverse order, that is j cross I. J cross I would give you negative k. You will get this result but negative. Suppose you go I cross k, I cap cross k cap. What do you get? The result is j cap only but with a negative sign. I hope everybody understand this. So this is all about cross product. Now we have the properties as well. Vector product is not associative. Okay, is it commutative? Where that slide has gone. Okay, it is commutative. I think a little bit of this is there. Yeah, vector product in terms of component. In terms of component, we calculate it by the determinant way. Okay, determinant way. How do we do this? A cross B, we write ijk in the first row, and then a1 a2 a3, then b1 b2 b3. If it is b cross a, then I'll write second row as b1 b2 b3 and the third row as a1 a2 a3. So that will give me the result of a cross b. Okay. Now I come to this slide. I think the first 4 points are missing. I'll write it down. First of all, a cross b is not commutative. A cross b is not equal to b cross a. Okay, Sujan? Yeah. A cross b in fact is equal to minus b cross a. Then that is, it is not commutative. Okay, it is not associative even. You cannot write like this. Then we have a point a cross b is 0 vector. Then it means either a vector is a 0 vector or b vector is a 0 vector, null vector I mean, or a is parallel to b or collinear to b. Then we have a scalars multiple of a cross b, we get this. Scalar multiple of a and b, mn are here, so we can write like this. And yes, this is important, distributive property. A cross b plus c is a cross b plus a cross c. Okay, 1 hour is gone. Yes, Tarun, I am aware of that. So let's do, and sine theta can be written as a cross b mod upon a cross b. Okay, let's do one question. So we have A vector, we have C vector, and a vector B is such that A cross B is C and A dot B is 3. Then mod of B is equal to. Can somebody answer me? Mod of B is equal to. So we go to the next slide. A is ijk and C is j minus k. Okay. So we make use of the next slide. Yes, Tarun. A vector is I plus j plus k, and B, what is C vector? C vector is j minus k. And what else was given to us? We were given B is such that A cross B is C and A dot B is 3. 3. है ना? So we have A cross B is C vector. A cross B is C vector, and what? B dot C. B dot C is 3. Okay, this is what is given to us. Now we are being asked to find out B vector. How would I do it? Tell me. So magnitude of B I need to find. Okay. So A cross B is C vector and B dot C is 3. Okay, if you are aware of, let's say, that vector product or STP, scalar triple product, then it becomes very easy. But we are not using this right now. So B vector, what I can consider? If I take alpha I plus beta j plus gamma k, and then we have mod of B equal to, okay. Yes. Do you know some connection between A cross B and B dot C? Anybody? Anyone who knows connection between A cross B and B dot C? Okay, let's have a look. I take mod of A cross B. Okay. What is that equal to? That would be equal to mod A mod B into sine square theta. Am I right? Hello? Now, if I do squaring both sides, it will become like this. Oh, sorry, sine square I have already done. Okay. A dot B is equal to 3. A dot B is equal to 3. Yeah, I know. A dot B. A dot B is given, not B dot C. Have I done something wrong? A dot B is 3. Thank you, Snigdha. Thank you. Not B dot C, it is A dot C. Just a moment. This thing is A dot B. That is 3. Okay. Now A cross B is mod A square mod B square sine square theta. Are you aware of this? Yes, thank you, Snigdha. Thank you. Now A cross B is, now this is Lagrange's identity. Now I can write sine square theta as 1 minus cos square theta. Is it okay, students? So what I can write? Mod A square mod B square into 1 minus mod A square mod B square cos square theta. Is it okay? Now mod A plus B is C vector. So I can replace this by C. Mod C square is equal to mod A square. Can somebody answer me what is mod A square? So that is mod A is 1 square plus 1 square plus 1 square, that is root 3. That is mod A. So mod A square would be 3 mod B square minus. Can somebody tell me what is this? Is this not A dot B whole square? So from here I get mod C square. C is what? J minus K. So mod C would be root 2. So mod C square is 2, 3 mod B square, and A dot B is given to me as 3. So minus 3 square. Am I right? So Chiru, you have given me the answer. So 9 plus
9 and 2, 11. 11 by 3, that is mod b square. Something wrong in it? No, it's right only. So what is mod b? That was being asked from me. That is under root of 11 by 3. Is it okay, students? Yes. So under root 11 by 3 is mod b. That is our answer. Okay. I hope everybody understands this. We go on to the next slide. Yes. Geometrical interpretation of vector product. Now, can anybody tell me what is the significance of vector product? It gives you, in fact, the area of the parallelogram. If a parallelogram is made by A and B vector, the adjacent sides are A and B, then A cross B gives you the area of the parallelogram, mod of A cross B. Okay. Area, by the way, is kinematics any day. RKS, kinematics you want from me? Yeah, of course I can teach, but but yeah, physics I don't take. But yeah, kinematics, mechanics, dynamics, statics is a portion of maths also. Statics, dynamics is a portion of maths also. I can take that, I know, but I think. Oh, thank you, RKS. I really am flattered by your appreciation. Okay, so this is area of a parallelogram. I hope everybody understands. That is A cross B. Achha, by the way, area is a vector quantity or a scalar quantity? Tell me, students. Area of a parallelogram, area of any figure, is it a vector quantity or a scalar quantity? So, achha, by the way, we have one more formula with us. Area of a parallelogram can also be expressed as half d1 cross d2. So if diagonals are given, then also we can find the area of the parallelogram, and that would be given by half mod of d1 cross d2. Okay, that would be the magnitude of the area. Yes, Basavaraja, you are right only. It's vector, no RKS. It's a vector, beta. Area is a vector. You remember, you have B cross A as the flux, magnetic flux. You have B cross A, na? So you are taking cross product from the area vector. I hope you remember. So here we have half d1 cross d2. That's area of a parallelogram. Area of a plane quadrilateral. So if AC and BC are the diagonal, we can make use of this formula as well here. Now, if, achha, by the way, there is another formula for area of a triangle of ABC. If ABC are the position vectors, mind you, then its area is given by half A cross B, B cross C, C cross A, and whole mod. Okay? Yes, no problem, RKS title. Half would come outside it. Okay? This is one of the formula for area of a triangle. But this is only when A, B, and C are position vectors. I hope everybody is okay with this. So, let's go ahead. The area in square units of the parallelogram whose diagonals are along this. So, this is just a plain application of whatever we have done. Instead of this, we'll make use of that how the area of a parallelogram is half d1 cross d2. Okay? Instead of this, we solve this particular thing. So we have a parallelogram, okay, and this vector is A and this vector is B. Now this diagonal is d1 and this diagonal is d2. Now what did I say? The area of the parallelogram is half mod of d1 cross d2. That's what we wrote in one of the formulas. No, area is not independent of the direction, Chinmaya. Area we consider as vector. Okay. Now d1 is what? Tell me. D1 vector is A plus B. Am I right or not?
And D2 vector is what? It is A minus B. Am I right? So parallelogram area we know is A cross B. Am I right? Parallelogram area. Mod we are taking, mod of area. So if we consider D1 cross D2, what do we get? We get A plus B cross A minus B. Is it okay, students? So what do we get? We get half A cross A minus A cross B plus B cross A minus B cross B. Isn't that right? Simple distributive property I am applying. It distributes over addition. So A cross A will be what? Sine 0, it is 0. Theta here is 0, so sine 0, B cross B is 0. I can write A cross B, B cross A as minus A cross B. So that is minus 2A cross B. How did I write? B cross A, I can write it as minus A cross B. Am I right? Meenakshi, only scalar triple product and vector triple product is left. So this would be equal to A cross B. Minus will be neglected. 2 and 2 goes. So that is what area of a parallelogram is. That's how we did it. Okay. Only STP and VTP is left. Scalar triple product and vector triple product. Okay, Meenakshi. Now we come to scalar triple. This is the penultimate topic. Scalar triple product, that is also called as a box product. Okay. So box product is defined as the dot product of one of the vectors with the cross product of the other two vectors. This is how we represent A dot B cross C. So tell me, first, will you operate dot or will you operate cross? So first you have to operate cross only, because then a vector would result, and that vector, only that vector can be made, you have to take a dot product with that vector. If you first do the dot product, then it results into a scalar. So a scalar cannot be cross multiplied with a vector. So if it is written in this manner, then the cross product has to happen, then the dot product. Okay. Cross means vector product. Cross means vector product. I hope you understand. Okay. Now, A boss product of ABC, this we write it like this, and then A cross A dot ABC STP is expressed like this determinant. Okay. This is how we get. How some doubts in Singage? Okay, Saraswati, I'll do that. I'll send you the solution as well. Okay. Now let's come to the properties of STP. So when we talk about STP properties, we write, if there is a scalar can be taken outside, and distributive property, if the first vector is A plus B, then C, then D, then it can be split into two box product, A, C, D, then B, C, D. The necessary and sufficient condition for three non-collinear vectors ABC is coplanarity. So this is the condition for coplanarity. Condition for coplanarity. Okay. The box product is to be 0. I hope you understand. I'll ask sir if it can happen that we can devote some WhatsApp number, some dedicated from Career 360, so that you can drop down your doubts and we can send a solution to those questions. Okay.
Now, geometrical interpretation of a scalar triple product. So, geometrical interpretation is, I think I missed one slide. Yeah, this one. So, what we are doing in actually when we take the box product of ABC, what actually we are doing is A. This is A only, है ना? A slight typo error. So, actually, volume of a parallelepiped is what we are calculating when we are calculating STP. How? What is parallelepiped first of all? I hope you understand what is a parallelepiped. A parallelepiped is, you consider a matchbox, okay? Think of it that you have holded a matchbox in your palm. You get hold of the base of the matchbox and give it a slap on its side. So it will the base will be in your hand, but the upper portion will become like this, as if it is shown in this figure. It will get tilted like leaning tower of Pisa. Okay, this is how it will become. Am I right or wrong? Tell me. There is a box, you have holded it by the in the palm, and from the right hand side or from the left hand side, you give it a slap. When you give it a slap, it would turn as if it becomes a leaning tower of Pisa. Okay, so this is known as a parallelepiped. Okay, a parallelepiped mathematical condition is that the opposite edges are parallel. Okay, so cuboid and cube etc. are all part of the parallelepiped. Now, what do? This is A vector, this is B vector, this is C vector. Now, if I do A, B cross C, the cross product has to be done first. So when I take B cross C, I'm talking about this area of this parallelogram. Isn't that right? Yeah, you're right, Chinmay Joshi. That's a better example. A pack of cards pushed slightly. Thanks, Chinmaya. So this is the area which we have calculated when we did B cross C. Then this is BC sine theta n cap. Now what I do, A vector has to be taken the dot product with n vector. N vector is nothing but this vector, B cross C. N cap is in this direction. I mean perpendicular to the area. This plane, not perpendicular to the area, perpendicular to the plane, this direction. So when I do BC sine theta A dot n will fetch me A, mod of n would be 1, and cos alpha. Alpha is the angle between the adjacent side and the perpendicular vector. This is alpha. So basically, this would be the height of the parallelepiped. So height of the parallelepiped. So A cos alpha is nothing but height, and BC sin theta is nothing but the area of the base. So when you multiply area of the base with the height, you actually get the volume of the figure. That's how you do, no? For a cylinder, if you say, for a right circular cylinder, the area of the base is pi r square. If you multiply by its height, then you get pi r square h. That's how you get the volume of the figure. Okay? Now, let's come to the area of a tetrahedron, volume of the tetrahedron. It's 1/6 of the box product of ABC, where one of the vertex of the tetrahedron is origin, and the other three vertices vector products, the position vectors are ABC. Okay. Now, next is what? Vector triple product. Now, when we talk about vector triple product, geometrically it doesn't have any great significance, but let's look at the formula. Like the way STP had the volume of the parallelepiped. A, let us call this as 1, this as 2 vector, and this as 3 vector. Then what do we get? A dot C, that is 1, 3, 2, and 1, 2, 3. That way you can remember A dot C into this is not dot product.
This is not dot product. Please don't get it wrong. So it is in fact A dot C B. You write B like that only, because A dot C is ultimately going to give you, ultimately it is going to give you a scalar multiple of B minus A dot B, and you have C. This is a scalar, simply it is multiplied to C. Okay, I hope you understand. So vector triple product, in what do we have here in notes? A cross B cross C is this, okay, and similarly if I write A cross B cross C, so that would be minus of C cross A cross B, है ना? Because A cross B is minus of B cross A, minus of B cross A. So when we write this, I get C dot A, and this again no dot is there, minus C dot B into A. So in general we don't have this equal, and if we have these two equal, then the vectors A and C are collinear. Why? Because A cross B cross C is this, and A cross B cross C is this. If we equate these two, then C dot A, C dot B is cancelled. I get A dot B C is equal to B dot C A, है ना? So that means some scalar multiple of C is equal to some scalar multiple of A. Okay? So we get C and A as collinear. I hope you understand. Yes, students, I hope you understand it. So we do one question. It's a very important question. There are questions based on vector equation. Hai, these are kind of vector equations. So A and B are not perpendicular. Okay, please mark it. C and D are two vectors satisfying. C and D are two vectors satisfying. B cross C is equal to B cross D, and A dot D is 0. Okay, then vector D is equal to. So what I do? Yes, student, you can also try. Tarun, B you are getting. Okay, very good. So fast. Ashit Shekhar, B. Okay. So B cross C is equal to B cross D. What I do, I take A cross both sides. A cross both sides. So I get A cross B cross C is equal to A cross B cross D. Am I right? Now, let me go ahead with this on the next slide. So I have A cross B, A cross, what was that? B cross C. And the next one was A cross, what was that? I just keep forgetting, huh? Now B cross C, B cross D. Okay. I have B cross D. Okay, students, just hang on. This is the last question we are doing. B cross D. Okay. So we solve it. We get A dot C B minus A dot B, that's the left hand side opening, C is equal to, this would be A dot D B minus A dot B D. Okay. A dot B D, A dot B C. A dot D is what? 3, I think. है ना? A dot B is 3. And A dot, and what else was given? What else was given? I'll have to look once more here. B cross C is B cross D. C and 2 vectors A and B are not perpendicular, and A dot D is 0. Sorry, A dot D is 0. I wrote it as 3. So A dot D is 0. That is 0. So I'll write it 0. Okay. So this is A dot B is C, A dot C is B, and A dot B D. What do I wanted to find? अरे यार, the vector D is equal to, huh? So I'll find it like this. I'll get D as, I'll take this on the left hand side. So I get A dot B D. I take these things on the other side. So A dot B C minus A dot C B. Now this is a scalar, I can divide it. So what do I get? D. A dot B cancel. So I get C minus A dot C upon A dot B. Am I right? Into B. So which is this choice? Chinmaya, you want me to, this is choice B, I think. Yes, as you all said. Now, Chinmaya, condition for collinearity is if A and B are collinear, then A is equal to lambda B, where lambda is a scalar. This is the condition for collinearity. Okay? I hope, students, you understood and you are able to revise most of the portions. So, any doubts? Yes? Anyone with a doubt? I'll request Career 360 to devote some WhatsApp number where you can post your doubts. Thank you, Arshad Shekhar. Thanks again for your appreciation. So I'll request them to provide you with some WhatsApp number where you can clip the photos of your doubts and you can send it across. Okay? So, okay, students, I hope this was interesting for you. Is there any condition other than what you stated for collinear? No, nothing else. Thanks, RKS. Bless you. Have a great day ahead. Okay. Thank you, Snigdha. Thanks for your appreciation. Bless you. Okay, students, I take your leave, and tomorrow again we'll meet with questions on vectors. Okay? Bye. Have a great day. Bye, Meenakshi.